Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, so for this problem, we are given what the wavelength is at different values of N, and we're going to calculate what the energy is in kilojoules per mole. One thing to note before we start is that because all those wavelengths are given in nanometers, when we use them in our equation, we're going to multiply them by 10 to the negative ninth in order to get them in terms of meters, not nanometers. So for each problem, we're going to use the same equation of E is equal to HC over lambda, where H is our constant of 6.626 times 10 to the negative 34. C is our constant of 3 times 10 to the 8th. And then our wavelength, we'll start with the first one when N is 3. Our wavelength there is 656.3 times 10 to the negative 9th meters. And then we want our energy in terms of kilojoules per mole. So in order to get into kilojoules, we will need to divide by 1,000. And in order to get per mole, we're going to multiply by 6.626 times 10 to the negative, wrong problem. Our Avogadro's number of 6.022 times 10 to the 23rd. So when we multiply all that out, we get an answer of 182.3 kilojoules per mole. And we're going to follow those same steps for our other two wavelengths. So when N is equal to 4, our wavelength is 486.1 nanometers. So we have our value of 6.626 times 10 to the negative 34 for H. Our C, which is 3 times 10 to the 8th. Our wavelength, which is 486.1 times 10 to the negative 9th to get it in terms of meters. And then multiplying again by Avogadro's number, 6.022 times 10 to the 23rd. And also dividing by 1,000 to get it in terms of kilojoules. When we do that, we get 246.1 kilojoules per mole. And then the last one, which is when N is equal to 5. Same process, just a different wavelength. So 6.626 times 10 to the negative 34th times 3 times 10 to the 8th, our value of C, divided by 434 times 10 to the negative 9th meters. Multiply that to get it in terms of moles as well. And then divide by 1,000 to get it in kilojoules. And we'll get an answer of 275.6 kilojoules per mole.